Good day and welcome to ChefConf 2020, the COVID-19 edition. My name is Robert Mortimer and I will be talking about implementing security standards, otherwise known as adventures in compliance. On the agenda for today we have knowing your standard. Don't skim it, don't oversimplify, do not try and condense it down. Everything in that standard is usually important. Know your infrastructure. Get the visibility you need. You need visibility if you are to remediate sensitively. Remember, you're a sysadmin. If you break things, you get to own the pieces. It's often not a pretty sight. And I would implore everybody, don't just crunch the numbers. Be sensible about what you go for first. Make sure that you add maximum value with the time you've got and start adding value as soon as possible. So, what standards are available? Well, pick a standard, any standard. Sometimes seems that standards are like PHP frameworks. Basically, the number of PHP frameworks was always reputed to be the number of PHP developers you had, plus at least one, because everybody had their own framework. Back in the day, Microsoft used to argue that competing standards were good for free market ideas. This was their way of trying to foist the Word document format as a standard on the rest of the world. Pretty poor argument then, pretty poor argument now. However, get over it. It's not going to go away. There are lots of security standards. There's the PCI DSS one for the payment card industry. There's the National Institute of Standards and Technology in the USA. There's the NSA. When they're not busy listening to your phone calls, apparently they're busy giving you information about how to stop them from listening to your phone calls. Back in Europe, we've got ISO standards. There's the Centre for Internet Security. There is a plethora of standards. So, what are we going to choose? Well, for brevity and for the fact that we've got to choose something, I'm going to choose CIS. CIS is a pretty good standard. It's quite workable. It doesn't become over prescriptive. It allows you to actually use your machines. It's community driven, so there's a lot of bits and pieces around for it, a lot of resources. It's also supported by Chef Automate, and that's important in the context of where and why we're having this talk. This is our example. We could have run with others, but this is the one I'm going to run with. So, what's in a spec? Well, if you look at the opening document of the CIS standard for RHEL 8, that's one of the new ones, you can see there's a whole load of checks. There's things like disabling unused file systems and a list of file systems. There's a whole load of partitions that you're meant to have that make you think that you're actually running a Red Hat install from somewhere around circa 2005. But all these things are part of the standard. So, what do all these standards consist of? Well, let's just drill down into one. We'll pick the first one there. We'll pick 1.1.1.1, ensuring mounting of CramFS file system is disabled. Now, you'll notice that these come in two types. There are scored and not scored. Normally, that's there for a fairly good reason. Scored are the ones that you can quite easily find out what the settings are with bash script. Not scored, not so much. So always be a little bit hesitant when you're trying to automate anything that says not scored. That said, we're going on to our standard. So, drilling down. Description of the standard. This is important. CramFS file system is a compressed read-only Linux file system, yada yada yada. Yeah, you know, that tells us a little bit about what it is. Rationale. Removing support for unneeded file system types reduces local attack surface of the server. If this file system type is not needed, disable it. Yeah, pretty good. What we're looking at here is if people manage to get files to the machine, they can actually mount those files if they have a formatted file system inside. That may allow them to abuse the privileged systems on the server and execute code. So it's always a good idea to try and stop people mounting their own file systems, especially as an unprivileged user, if you don't want them executing arbitrary code. And that's the sort of rationale behind this if you expand it out a bit. So inside the standard there's a handy little audit section, and it says basically you do a mod probe to see CramFS and it should say install bin true. And if you actually see if the module is loaded, it says nothing. Now there's a question here, why would it say it's loaded and it's not loaded? A little bit Schrodinger's cat there. It's both dead and alive at the same time. The reason for that is, in the remediation, what we have done is we've actually configured it so that when we ask if it's installed, it says true, regardless of whether it's been installed or not. And we have then unloaded the CramFS module. And this is the remediation that is expected for this actual control. So if we have a look at a bit of the InSpec, this is some InSpec that was provided by Chef. It's part of their Automate setup. And we can see that it does 3 tests. It checks that the module isn't loaded, it checks that it should be disabled, and it also checks that it should be blacklisted. Now I've probably overlapped my controls a little bit here because we didn't actually blacklist this control. However, I've probably taken this from another Red Hat version. It's pretty easy, simple. What we're going to do is we're going to run the InSpec. We're going to identify the machines that are not compliant. We're just going to remediate the offending machines because we've got this random bit of bash script that we can run against them. And then we're going to have a meeting about what broke and what chaos we caused. Because this is a recipe for disaster if not treated with a degree of sensitivity. So, first of all, know your standard. The rationale: removing support for unneeded file system types reduces local attack area, yada yada yada. Is this a security problem? Do I need a full security audit for each request? If a customer asks for this, is it just okay to say yes? Am I okay with that? And the fact of the matter is, it says so in the standard, if not needed. If my user base actually needs a CramFS file system, there is no actual thing in the standard that says I shouldn't actually give it to them. There's not even a thing that says I should look for alternatives. There's not even a thing that says I should be looking for alternative ways to produce that functionality. All we're saying is, if this functionality is not required, we should not be loading this module. Now, the first mistake comes here. It's very easy to roll security standards into a security system, which means that all of a sudden, when somebody wants to actually use any of this thing, it is, quote, going against security standards, and that's considered to be a bad thing, and then you need to effectively grovel or compete to try and get your thing turned on because you are breaching the perceived safety of the machine. Know your standard. Know that some of these things are effectively an auditing function. You must justify that you're using it. If you're not using it, take it off. However, if you need it, by all means need it. It says so in the standard. We can quite safely say CramFS. Yeah, we have no CramFS. Very few people have CramFS. I'm pretty sure we've got no CramFS. However, do you have any Internet of Things devices that are running Linux that you're looking after? Possibly not, depending on your business. Do you have anything that builds some images for Internet of Things devices? Well, there's a possibility that you do. So somewhere there is some developer that's got some pipeline that's cranking out CramFS file systems to go on IoT devices. If you just remediate this, you're going to spoil their day. Maybe there are some EPOS machines out there, something with an image on there that's been supplied and you're running some Chef, and you may not actually have an absolute up-to-date knowledge of how those machines are built. They might have some CramFS in them. What's driving your public display screens? Have you bought in some various Linux devices that you're using? When they start up, do they simply unpack a file system into memory and off they go, so that when you turn them off again, they do not retain state? There's a whole load of things that if you're not careful, you can break unless you really know what you're doing. So, are you really sure there's no CramFS out there in your infrastructure? Look at the InSpec. The InSpec has 3 tests. The last 2 there weren't part of my build. That means that every single build in my fleet of 5,000 odd machines will fail. Now there's a difference here, there's a subtle difference. There are ones which have failed because the file system is not disabled or blacklisted, and that's fine as long as it's not loaded, because not loaded is a very good sign of not in use. What we actually need before we start remediating is another InSpec control, and basically this one goes around and it says, where are we actually using this thing? Because we could be able to run this and find that meh, we're not using it at all. And if the answer is meh, we're not using it at all, then we can be pretty gung-ho about how we remediate these suckers. However, we might find that there's a whole load of stuff creeps out of the woodwork and we think maybe we should be a little bit more careful. Now with ChromeFS this isn't really possibly a big problem. However, bear in mind that this sort of procedure works for other controls, and those other controls include things like, if not using NFS, disable. Now if you're using a whole load of NetApps or other SAN architecture to deliver a whole load of file systems over NFS, that will create you the sort of chaos that will make you unloved. So be sensitive in your remediation. Try not just to run random bits of bash. This is a remediation module of mine. Basically it takes the name of the file system module, and in there you can see as part of the remediation it first checks that the file system is loaded. If the file system is loaded, it does not remediate it. The reason that you have this cookbook and this logic is because you can effectively deploy the remediation to your estate, and you might even get 100% compliance. You might get 95% compliance, but you probably won't break anything, and that's important. Not only that, you will get visibility of the 5% that are going to cause you your issue. And again, so long as you haven't been too aggressive in getting this actual check into your security standards, the remediation here should simply be to obtain some sort of evidence that the person who owns that machine is actually using the functionality that is provided by the file system driver. So, remediation, just in recap, run the InSpec, make sure you get the visibility. The InSpec provided does not always give you the visibility that you require. If everything fails, you may need to differentiate between different states, those states being actively disabled and in use. For example, if people are using NIS, you can look in the configurations, see if there's an actual NIS server named. If there's a NIS server named, you probably don't want to disable NIS. If you've got NFS, you can use OHI to see what the actual mounted file systems are. You might decide that if they've got NFS file systems mounted, that's probably an indication that you want to back off remediating their NFS setup. So be careful, do some detection, remediate with a degree of sensitivity. Identify the machines that are not compliant. When you've got that final run, and you've got that 5% of machines that aren't just fixing themselves, don't take that as your sign to just be more aggressive. Go in, find out why, take the time, try not to break stuff. Back to remediating the offending machines. Make sure your remediation code is sensitive. Now you've got two sides here. You've got one side where you run InSpec. Your InSpec discovery code can be quite fine-grained. However, I would advise against modifying the Chef InSpec to simply pass the test when a service or package is configured and in use, as this reduces the visibility of where you actually have something used that should be owned by the machine owner and be being used. You've got three buckets of machines. You've got a bucket of machines where the service is not running. You've got a bucket of machines where the service is running and not used, and you've got a bucket of machines where the service is running and is used. You need to be able to identify and distinguish between all three of those states, and you can do that in the InSpec, or you can do it as part of the remediation. Your mileage may vary depending on which end you tackle this. And in some organisations, if you add extra InSpec, you're just setting yourself up to add extra fails into the stats, and that is normally frowned upon. I would also tend towards doing it with the remediations, because that way you have a very vanilla set of InSpec, apart from the odd additional rule that you have to create, possibly, that nobody can argue that the InSpec is not a valid test. Once you start editing the InSpec, you can get into a discussion with your security group about whether it is now actually holding up to what can be seen as the true underlying intent of what was meant to happen. And in this case, if it all goes well, instead of having a meeting to point fingers at each other about what broke, you can have a meeting to say where you're going to go to next. So, prioritise sensibly. Not all non-conformances are the same. Some will take more work than others. If you expect a lead-in time, start work immediately. For example, if you have a load of old RHEL 6 machines that have been in for about 5 years and some bright spark thinks you want to retroactively enable SE Linux on there because you've had it turned off for 5 years, that's a non-trivial task. That's going to take you a while. That's going to take you quite a bit of talking to your customers to see what they're actually running and whether that's going to be possible. Bear in mind that some bits of software you can break the license, you can break the support agreement if it's not in line with the vendor's configuration. So there might be a chunk of machines which you just can't do that and get any money out of your support contract. That sort of thing needs to be surfaced as soon as possible. You need to get onto that. Don't leave the hard stuff till last. Some will require cooperation from other teams. Look through your specs, determine which ones are going to require some cooperation. Make sure that you try and contact those teams as soon as possible. Make sure that you have a contact to talk to. Reach out early. Once you've done all the easy stuff, it's too late to be asking questions and doing admin trying to find people to talk to. Remember, not everything carries the same risk. You might desire to move all the higher risk things to the top. Yes, management will probably be looking at the numbers. How many have you remediated? How many has the number gone down by? That's fine. But your pride as a security professional should really prompt you to tackle the things that are really dangerous first and move down the list to the things that are less dangerous. Remember, not everything has the same risk. This is a drone. This is a drone. These things are not the same. Unfortunately, as you move higher up your management hierarchy, these nuances get left, and as a result you just get those are both one, those are both two drones, and you need to get rid of one drone. One I can get rid of with a fairly good squash racket, the other one would probably make a mess of my car. You know, there's a difference between how these are and what are done, and at the end of the day, when they're just expressed as numbers, there is a great temptation to just go swat the flies. However, try and be a professional. Try and make sure that you're tackling the things that are really dangerous first. Start with the high security risks. Start reaching out early if you need cooperation. Start planning the hard stuff up front. Use easy stuff to fill the time. Try and resist crunching the numbers. Don't break stuff. In summary, run the InSpec. Make sure you get the visibility you want. Identify the machines that are not compliant. Investigate a sample. Find out why they're not compliant. Remediate the offending machines. Be sensitive. Remember, not everything carries the same risk. And finally, try not to pour sand in the machine. Don't make minor admin tasks for installing valid software into big security things that need a full security paraphernalia throwing around them. Any questions? I'll be here, networks permitting and Zoom not crashing.